day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by Gauteng Department of Education in collaboration with Sabono Discovery Center and broadcast by Pagama Research and Development. You can send us a WhatsApp on this number 079 578 2908. Please send us your questions on that number 079 578 2908. Right. Today's lesson, as I say, it will be technical mathematics, but the topic today will be integration. Integration is part of our curriculum, and the topic at the end of the year is plus minus 15 marks. So in other words, we are having plus minus 15 marks on this question. So let's see how we can get this 15 marks. So there are three things that we're going to do, and I'm just going to explain them in the next slide. All right. The objective of this lesson is, at the end of this lesson, you must be able, as learners, you must be able to understand the concept of integration as a summation. So in other words, we're adding bits and pieces of stuff here, which, for instance, will be the definite integral and as the converse of differentiation. In other words, it's a reverse of what we have done earlier in term 1, which is differentiation, which is called the indefinite integral. Number 2, we must be able to apply the forms of integrals as a converse of differentiation. So we must be able to use the rules to do this integration. Number 3, we must be able to integrate the following. So k x to the power of n, where n is a real numbers, with n not equals to -1. So in other words, you'll see when we do this question. So we're talking about questions like, if for instance, I've got 2x to the power of 3. So how am I going to do that? So we're going to do questions based on that. The other one will be k over x. So for instance, if I've got 2 over x, right? So we need to know how to integrate that. Number 4, we must be able to integrate polynomials consisting of terms of the above form. So the ones that we have done there, we need to do the polynomials. We need to integrate the polynomials, and then we'll show you the rules there. Number 5, we must be able to apply. Now we're going to apply that integration to determine the magnitude of the area. So in terms, when we talk about magnitude of the area, you realize that in area, we don't have a negative area. So we're going to be looking at positive areas included by the curve and the x-axis. Very important. It's only when we have the x-axis and that area that is between the x-axis and the curve that we can then determine the magnitude of that area there. So it will be the x-axis and the coordinates. So the coordinates will be given. So for instance, I can be given x at a and x at b, where a and b are going to be our integers. So it can be negative, it can be positive, so we must be able to do that. Now let's look at this topic called integration. Now, you see, in mathematics, we have all this, most of the processes that can be reversed. You know, when you're doing exponents, then you know you can do the logs. So with exponents goes with the logs. So I can change something from exponent to logs and logs to exponent. For instance, if I have addition, you know, the reverse of addition is going to be subtraction, that we know. If I'm not adding, I'm going to subtract. And the reverse process of multiplication will be division. So in mathematics, we have this kind of scenarios. In the previous term, we did differentiation, remember? Which can also be reversed. So differentiation can be reversed also. So the reverse process of that differentiation, it's what we call integration, which is the topic that we need to do today. Sometimes it is called the antiderivative, because remember we derive Here now we're doing the antiderivative. We're going to do the reverse of differentiation. Now let's look at this. In differentiation, you know, if I'm given f at x, it's equals to 4x squared. And I want to derive. Remember how do we derive? The 2 multiply with the 4, so we get an 8, and we subtract 1 from that 2, then we get x to the power of 1. Then we say the integral. Now, look at this. The integral of 8x will be this. So when we're doing activities, I'm going to show you how from here to there, how do we take this one from here to there. Now look at this sketch here. So we say we integrate, I integrate that, and then from there, I differentiate this one. When I differentiate this one, then I get that one. When I integrate this one, then I get that one. So it's a circle. So we have integrate, differentiate. So if I differentiate this one, I'm going to get, if I differentiate 4x squared, I'm going to get 8x. But if I integrate 8x, I'm going to get 4x squared. So we'll show you how we're going to do that. Now, before we do the activities, let's check what is happening here. In integration, the symbol that we use for integral is that we call it a stylish S. So that S here, but we don't write it like that. So look at how we write it. So we write it in style, so it looks like that. Okay. So, and don't write a smaller one, just write, at least it must be a bit bigger, so that then you are able to can write down your functions next to it there. This is called the integral symbol. What is there? The 2x there is a function that we want to integrate. So what is there is a function. So here it is slices along the x. So remember we said we are summing up bits and pieces of stuff here. So when you're summing up, therefore, what are we summing up in this case? We are summing up the x's. So you see we have an x. So if, for instance, I had this two p, for instance, therefore I'm going to sum up the pieces of p, not of x, because I have p here, so I'll have a p there. So in other words, I'm going to be integrating the p. So if I've got that, and I've got 2p plus 3q, but I say I want d of p, so I'm only going to concentrate on the p. So which means that our 3q there is going to be our constant. Now, let's get to the next one. If we differentiate the following, now remember, I've got 3 functions that I've put there. So we want to differentiate the following. So if I differentiate this part, remember the differentiation of a constant is 0. So which means that I'm going to get 2x for that. If I differentiate this one, still the coefficient of -5 will be 0. So in other words, I'm going to get 2x, so the answer will still be this one. If I differentiate f of x here, there I'm going to get 2x because that is a constant. So it means that I'm still going to get 2x. Therefore, we notice that the above 3 functions will give us 2x when differentiated. But you'll see when we integrate now, from what we have as 2x and now we integrate, what are we going to get? Now, here's an example. If I integrate 2x, I want to find the integral of 2x. So if I need the integral of 2x, I'm going to get x squared. As I say, in the next activity, I'm going to show you how we're going to do that. We'll go back to this. So we're going to get x squared. But now, because we don't know what will be the value there, because remember, before I said, when we integrated that part, we get 2x, this we get 2x, that we get 2x. But if I integrate the 2x, I'm going to get x squared only. But what about those constants? Do I know? No, I don't. So that is why we are going to use the letter C for constant. So we don't know what that will be. This C might be a -5, it might be +12, it might be plus 3 pi, so it might be anything. So that's why when we integrate that, we're going to use the letter C. Right, so the integral of 2x, it's x squared. plus c, which is the constant, because we don't know what that value will be. Now let's check out the first rule there that we have for integral. The general solution of integrals is in the form that. So if I've got this one given in that form, this is how I integrate that. Now listen to this. Now the integral of x to the power of n of dx will be the same as, now I take that x, and then from there I have my n here. What I'm going to do, I'm going to add a 1 on the n. Whatever answer I get here, I'm going to divide that whole thing by that answer. So it's going to be n plus 1. Then I'm just going to add my c. So it means if I've got, let's go back to the question that I've done. If I had the integral of that as 2x, now I want to integrate this. Now what do? Then I'm going to say it's 2x, it's going to be 2x, this is to the power of 1, so I'll have add 1 here. The answer that I get here, I'm going to divide that by that answer. So this answer that I'm going to get there will be 2x squared divided by 2. The 2 and the 2 cancels out. The answer is x squared. Do you still remember? We said the integral of 2x will be x squared. So this is the rule that you must know. You must use and you must know it. Okay, you must know how to integrate that. And remember, this one we said is plus c because we have a constant, where c will be an element of all real numbers. Right. Okay, getting up. The other one will be when I have, say for instance, 2x to the power of 3, for instance. All right, so now what can I do if I want to find the integral of something like this? So I'll do the same. The 2 will be there, which is our a in this case. Then I'm going to add the n plus the 1 on the n, and from there I'm going to divide by n plus 1. So in other words, the same principle there. So when I integrate, then I just write equals to. I no longer write the sign. Remember. So it is the same as in differentiation. We no longer write the sign if I want to differentiate. So then I'm going to have 2x. Once I start there, I'm no longer going to write that sign. Okay, so I'm already integrating, so I'm not going to write that sign. So I'm going to have 2x to the power of 4 divided by 4, which is going to be x to the power of 4 all over 2. So we're going to have that as our final answer, x to the power 4 over 2. All right, now, the rules of integration here, the integral of the reciprocal of that one. So the general solution of that will be, if I've got something like this, 1 over x. Now look at it. If I've got 1 over x, if I try to integrate that, let me try. I'm going to have the integral of 1 over x dx. So I'll have this one will be x to the power minus 1. Remember, in exponents. So if I'm trying to integrate this, I'm going to have x to the power minus 1 plus 1 divided by minus 1 plus 1. Look at this, what is going to happen here. So now I'm going to get x to the power 0 over 0. Now we have a challenge. And you can see I've got a division by 0, which is not allowed in mathematics. Okay? Right? Technical math. So now we have x to the power 0, which is going to be 1 all over 0. And we don't allow such in our technical maths. Okay? So now, it means that now what are we going to do when we have that? In this case, it's undefined for that. But to integrate this, this whole thing there, given in this order, will always be given by what we call the ln of x. That you must know also. The ln of x plus c. So where this thing here, because it's 1 over x, that thing there is the same as the log of x, basically. So we can write it like that, but we now prefer in integration to write it as ln of x. So please note that, it's very, very important. So if I've got, for instance, integrate 3 over x, d of x. So how am I going to get that answer? So it will be the ln, 3 ln of x. So in this case there, I'm going to write it here. So it will be 3 multiplied by the ln of x. So that's what we're going to get. When you do activities, you'll see what we're talking about here. Now let's start with activity number 1. I hope now we are ready to do our activities. Now have a pen and paper ready so that you are able to can do it with me. Right, the first one says, determine the following integral, and it's 2 marks. So the 15 marks that I'm talking about will be based on 3 things. So you'll have the how to find the integral, maybe the indefinite integral that I'm going to talk about just now, also the definite integral, and also the area, the magnitude of the area. So those questions there will be, I mean, your 15 marks will be based on those questions. Let's look at this question here. Determine the following integral. There we have that sign there, integral sign x to the power 4 dx. So in other words, our pieces there, we're going to concentrate on the x. So for 2 marks, what should we do? We're going to go, this will be equals to, you see, once I start integrating, I no longer put the integral sign. So I'm going to say equals to. So what do I do? Here's our formula there. We're going to say x to the power of 4. What do we do then on the power? We add a 1. From there, what do we do? The answer that we got there, we're going to say 4 plus 1. Then we just write it nicely there. It will be x to the power of 5, all divided by 5. And that is my final answer. Okay. Okay, so your marks will be, sometimes, I know, you know, when you're getting, you're now used to integrating, you just write your final answer. So the 2 marks will be for your final answer. Because most of the time, when you've done a lot of questions based on integration, you're then going to be able to can quickly see that this is easy. Let me just integrate from there. I don't need to write down the plus 1 and then plus 1 there, because I already know how to integrate. I know I must add plus 1 on the exponent. Then from there, I must then write down the answer as the denominator. Okay, that's 2 marks. All right. The next one here is for 3 marks. For 3 marks. So how am I going to get this question, this 3 marks? First of all, we have something like this. So I'm having the integral of ax to the power of n dx. You still remember that the one that we have done there? Now I'm going to show you 2 ways of doing this. 2 ways. Same, simple, and you can be able to do it in any way. So let's check this. Do I have to start? Remember, when I integrate, it must be in a certain form. So here, I'm going to start integrating because I do not have to simplify anything there. So when I start integrating, I'm going to say, now I'm going to say 3x, 3 plus 1 divided by 3 plus 1, which is going to be 4. So I'm going to have that. So my answer there is going to be 3x to the power of 4 divided by 4. So it means that if I derive this one, if I want to take it back, I just derive it, and then I'm going to get to that answer. So my final answer is going to be that. Now, the other way of doing this, I'm going to write a big O there. Okay. Now, the other way of doing that is, We can first write this 3 on the other side of an integral sign. So I'm going to have 3 and then x to the power of 3 dx, which basically is the same thing. So from there, I'm going to say the 3, and then I'm now integrating. So I'm going to say 3, and then I open the bracket. Then I integrate that part only, because that 3, I'm not going to integrate it. So that's fine. So then I'm going to have x to the power of 4 over 4. If I integrate that, then the answer will still be the same, 3x to the power of 4 over 4. Okay. But you see, it's the same thing. I've just taken the 3 out there, and then I put it there, and then from there I integrated it. Okay, for 3 marks. So this question is a must for you to get. The first question in integration, you have to get this question right. Practice this question. It's quite easy. Once you know the process, the rule, you will be able to do it on your own. All right, and get those marks. Now let's look at this one. You see, what are the pieces that are going to be summing up here is the t. So I have a t here that I'm going to sum up. So this is the one that I'm going to quickly do now. Now, how am I going to then sum up this? Before I can do anything, I cannot integrate when I have my t as a denominator. So I must change it, and then change it to become a numerator. The basic things that we need to know here is your exponents and your simplification. So here we're going to deal with exponent loss here. So I'm going to then say, this thing here is the same as, I haven't integrated, remember? So I'm going to say it's the same as 9t to the power negative 3. Remember your exponential loss? If I've got 1 over x to the power of n, this becomes x to the power of minus n. Remember your exponents here. Right. Now I can start integrating. So once I start integrating, the integral sign falls off. See, now I'm going to say 9t to the power minus 3. What should I do to the power? I must add a 1 and then divide the whole thing there by minus 3 plus 1. Which then going to give us 9t to the power of negative 2 divided by negative 2. So if I want to be smart with my exponential knowledge, then I'm going to write this properly. I'm going to say negative 9 over 2t to the power 2. Because now I'm now taking this one back there. So that becomes minus 9t to the power minus 2, but I can do that. But what am I forgetting here? Plus c. I think even in the previous one, we needed to go and do the plus c. So remember the plus c. Don't forget it, because we've got a mark for it. See, most of the time in our diagnostic report, the one that we used to check what mistakes were done by the learners, we realized that the learners forget C, like I'm doing now. Please don't be like me. So please have your C if you're doing indefinite integrals. Okay, right now. Okay, let's get to this one. Oh, nice one. This one, I think you already have an answer for this one. That's why it's 2 marks, because we already have an answer for that. Remember, if I've got 1 over x, for which this graph for me, it is a, remember we're also working with graphs here. So this graph here, it's for me a hyperbola graph. Okay, so with the hyperbola graph, we want to find out what is how do I integrate this function here. So 1 over x, how do I do that? The answer is very simple. So what should we write there? We're just going to write the ln of x. Okay, right. So that's so easy. This one is very, very easy. So you just write the ln of x, then you're done. Then you get your 2 marks. Okay. All right. Now, the next one, tricky one. I know you're thinking, that one, it's easy. I just write on the x there because they said we must add 1, and then from there we divide that one, we just say x plus 1. Oh, not that easy. Okay, so now for this one, if I have x as an exponent, this is what I'm going to write. And this you must know. So if x is an exponent, and this is what I'm going to write. So the answer to this one, if I start integrating the answer, so I'm going to put 2 to the power x as my numerator, then divide this by. So I'm going to say this is going to be the ln of 2, then from there plus c. In other words, the rule there will be equals to, if I've got a to the power of x, our rule there is going to be our a over the ln of a. Okay, so now the a part becomes there, and it comes also there on the ln. So the answer there, remember, you must also write the plus c because of the constant there. Because that thing can be 2 to the power of x plus something, plus 4, for instance. See, then exponential graph, then that exponential graph, when we write down when we integrate exponential graphs, this is how we write it. Okay, so the 2 marks it will be for that, and we're also going to give you a mark for the c. Okay, right. Getting right along. Now let's look at the other rules of different of integration. Now I've done that. We are going to have an exercise just now. I've done that, and this is one rule when we are integrating polynomials. Right, polynomials. Remember, if I've got a polynomial, now what we were doing there, we were integrating. There was no polynomial that we did there. So here we want to integrate polynomials. In other words, if I've got 3x squared plus 5x plus 7, how do I integrate all that stuff? Now, in this one, then we're saying the integral of f of x plus minus g of x of dx. How do I then do the integral there? So I'm first going to do the integral of f, and I say plus the integral. You see, now I'm putting the integral on that one. So the integral of g, and which is going to give me that. And remember the plus c that we always have. Okay, so we can integrate the sum or difference of 2 or more functions by integrating each term separately. So in other words, we can do each term separately, but I know once you get in the mood of differentiating, that becomes easy. You can just do it at once. But now let's see what we can do in the next activity. It says, determine the integral of x minus 4, of which our pieces is x. Love it when they say the pieces will be x there, and it's 3 marks. Now, what am I going to do here? So first I can integrate each part, and then from there I can then add them together. So here, if I integrate each part, so I'm going to have the integral of x of dx minus the integral of 4 of dx. So in other words, I'm integrating each part. So if I integrate x, I'm going to get, remember when I integrate, then I remove the integration sign. I'm going to have x squared, okay? But that must be over 2 because how do I get the x squared, remember? It's 1, because it's exponent 1 here. So it will be 1 plus 1, which is 2, and divided by that answer that we got. So that's 2 divided by 2. There, when I integrate 4, remember 4, it's 4x to the power of 0. Because x to the power 0 is 1. So meaning that I'm going to have to add 1 here, and then what am I going to do there? And then I'm going to say divided by 0 plus 1. So which is going to give me 4x to the power 1 divided by 1, which is going to be 4x. So the integral of 4 will be 4x. So in this case, I'm done with that question. I've differentiated in parts. Okay, then I've got the final answer. Sometimes you can just integrate from there. So after integrating here, I go straight there, then I'll get my 3 marks. Okay, so if I integrate that part, integrate a part, and integrate a part, then you're going to then get to the same answer. Okay, right. The next question, I'm going to give you 3 minutes to integrate that. No, you cannot integrate it in that form. You must first do something. I won't say what, but do something. And then from there, integrate it. You can integrate it in parts or you can integrate it once. But I think 3 minutes will be enough for you to do that. It's 4 marks starting now. Welcome back. I hope and trust you have already done that question and you got the answer. But let's see how you did that question. Please, if you finish your question, you can take a phone and take a picture and send us a WhatsApp on 079 578 2908 and we will definitely check your answer there. Now, determine the integral of 6x minus 1 in brackets, 6x minus 1 in brackets, dx. So the part that we're integrating is x. So there, what should we do first before you integrate? What do you do first? You are going to multiply out the brackets. So in other words, I'm going to have 6x multiplied by 6x, which is going to give me 36. I'm going to put this in brackets. x times x is 36x squared. So 6x multiplied by minus 1, it's 6x. Then the 1 minus 1 times 6x is 6x. And then I'm going to have negative 12x. And minus 1 times minus 1, it's plus 1. Then we are going to now integrate. Once we have that, then we integrate. Then we are writing equals to, because we are integrating now. Then what are we going to have there? So when you integrate, remember, we are going to say 36 x squared plus 1, all divided by 2 plus 1 is going to give us a 3. Then minus 12x, that's 1. Then we're adding a 1 here, so that 1 plus 1 will be 2. Then we have the plus 1. So remember the plus 1, we said it's going to be x to the power 0. We're adding a 1 there, and then 0 plus 1, it's 1. So now, so I'm doing it step by step because then I know now we are now going to, when we've practiced a lot, we'll be able to can do it without writing that step that I've written. So therefore 3 into 36 goes 12 times. So I'm going to have 12x to the power of 3. You'll see when I differentiate 3 times 12 is 36. So I'm going to get my 36x squared. So here the 2 goes once there, the 2 goes 6 times. So I'm going to have minus 6x to the power of 2. There I'll have x to the power 1, which is going to be my x. What did I forget? Plus c, where c is an element of all real numbers. Easy. Okay, so see the marks there, that one mark for that, and then mark for that, and we also have a mark for a c. Okay, so please make sure that you write that c. It's very, very, very important. Okay, the next one is straightforward, already simplified. It's fine. I can just go straight to integration. And with this one, I'm no longer going to write that step. So you know what to do by now. What do we say? We say 3 plus 1, it's 4, and there will be 4. So it will be 4x to the power of 4, that is divided by 4. Okay, then what about the next one? Integrating the next one. It's 2 plus 1 is 3, so it will be 2x to the power of 3. That 3 must go also to the bottom. You see, now we're getting there. So the next one we're going to say 1 plus 1, it's 2, but now we're going to write the 2 at the bottom. All right, the next one we're going to say it's 2, so it's 2 x there. So what do I write? It's x to the power 1, is going to be x, and remember it will be divided by 1, so I'm going to have 2x. So when I differentiate this one, you'll see it will give us the 2. So if I differentiate this one here, it's going to give me the x. If I differentiate that one, it's going to give me that. If I differentiate that, it's giving me that. So it's antiderivative. So the answer that I got there, it's antiderivative. What did I forget? Plus c. 1, 2, 3, 4, 5. So I've got 5. So that's so easy. If you get this question, you must just kill it. Because then you know that you have your 5 marks out of 15, then you're getting there. You're getting there with the 15 marks. Right. The next one, I cannot derive when I have that. So what should I do first? I must make a plane. Make a plane on the 3 over x squared. So I cannot integrate. So I must make a plane. So my plane will be to write this one properly as 3x to the power negative 2. And we have a dx. Okay, so how am I going to write my answer there? So I now integrate. So once I integrate, equal sign, normal derivative sign. Now, what should I write there? So it will be 2 plus 1 is 3, and 3x to the power 3 divided by 3 will give us an x cubed, because the 3 will cancel with the 3 at the bottom. So if I've got 3 there, and a 3 there, that cancels out. So my answer is x cubed. Let's go to the next one. How do I integrate that? I'm going to say, now this is plus 1. The minus 2 plus 1 will give me minus 1. And remember, I've got a 3 there. So I'm going to divide it by minus 1. So let me do it quickly. So I'll have 3x to the power minus 2 plus 1, all divided by minus 2 plus 1. All right. In this case, the negative and the negative is going to be a positive. Why? Because this whole thing there is going to give us negative 1. So the negative 1 times negative, the negative times this negative will give me a positive. That's why that sign has changed. On top, what am I left with? 3x to the power negative 1. But I want to be smart. I want to show my teachers that I know that this thing there can be over x, 3 over x. So that's proper. But now what am I missing? Oh, always miss that. So that is plus c. Don't forget that. So always write it plus c, because this is called an indefinite integral, because there are no boundaries here. So that's why we call it an indefinite integral. Okay, so with indefinite integral, we know that one must be plus c. All right. Okay, now let's get to what we call definite integral. How do I see definite integral here? How do I see the definite integral? Now, the definite integral is different from the indefinite with one thing. With definite integral, we have boundaries. In other words, we are having a boundary here from 3 to minus 1. So in other words, we're going to have our x being substituted. So we're going to have our x substituted. In the previous one, we never had any x substituted. So it's basically the same thing as we have done with your calculus. Because if I've got f of x, it's equals to maybe 3x squared. And I want you to give me the f prime 1. You know, it means that you have to derive and then substitute by 1. But if I just say derive, you are only going to give me 6x. But if I say f prime 1, so you're going to have 6 into 1 here. So in other words, you're going to have 6x derived. Then you say substitute by 1. In this case, we're doing the same, but we're doing it in boundaries. Now we're saying from 3 to minus 1. So how do we do that? Check this. Now, here I've written something here. I said, if I've got those boundaries b on top, a at the bottom of f of x and dx, then if I exchange the b and the a, in other words, the b goes up and the a comes down, then I need to change the sign of the integral, which is going to be a negative. Please note that. But I want you to just work with the one that has been given. Okay, so that makes it life easier. Because if I change this one and take it up and this one down, then I need to change the sign of the integral, which sometimes maybe if I forget, then I'm going to miss that mark. Now let's see what we're supposed to do here. How do I find the integral of 3? By now you know how to find the integral of 3. So the integral of 3 is going to be 3x. Nice. Okay. Now, where do I put, because I've already done the integration there. Where do I then put my boundaries? So I'm going to have a 3 there and a minus 1. Please, you must write down those brackets so that then you indicate your boundaries there, 3 and minus 1. Okay, but I'm not done, because then I've got a 3 and a minus 1. What should I do with those things then? I must then substitute them in. So first I must substitute by 3. Okay, now in this case, what you do is you are then going to subtract. Okay, so you're going to have, and you must note that, you're going to have one bracket when you substitute by 3, and the other bracket where you substitute by negative 1. All right. This is a very important step. You must know that. Then what do we do? we now work this one out. 3 times 3, it's 9. Okay. 3 times minus 1, it's minus 3. So we have a negative into, there we have a negative 3. And that will give me 9 plus 3, which gives me 12. Now we've got an answer there. So remember in the previous ones, because they were indefinite integral, we only left it at x. But this one, because it's definite integral, then we have to substitute the value of x. First by 3 on top, the upper bound limit, and the other one with the lower limit, which is 3, upper limit. Lower limit is minus 1. Substitute correctly, you get your answer there to be equals to 12. So this is very important, because now when you do the area, this is exactly what we're going to be working on. Okay. The next one, 4, upper limit 4, lower limit minus 2. What does this mean? It means that now we first substitute by 4, then we substitute by minus 2 after we have integrated that sum. So you cannot just substitute immediately there by 4 and by negative 2. That will be very wrong. Okay, right. Now we need to integrate first before we substitute. Let's integrate. Now, before we integrate, when we integrate, this can be integrated. So by now, let's hope and trust that everybody can now integrate. The integration of that will be 3 plus 1, it's 4. Divide everything there by 4, the 4 and the 4 cancels out. So you're left with x to the power of 4. But now I must put this bracket and indicate my boundaries now. You see where I indicate my boundaries after I've integrated. I'm stressing this so that then you understand that you must first integrate, then write with those brackets, write your upper limit and your lower limit. Now, from there, then I'm going to substitute. I've got 2 values there. So I'm going to substitute by both values with a minus sign. I'm going to stress again. So I'm going to have the first one here, I'm going to substitute. Okay, I'm going to put my square bracket. I'm going to substitute my x by 4. Okay, I'm done with that one. So now I'm then going to say minus the upper boundary, subtract the lower boundary. So now minus, then I'm going to say negative 2 to the power of 4. So I'm substituting my x by minus 2. What am I going to get there? 256, if I'm not mistaken. So now that minus the negative 2 to the power of 4 should be 16. Then I'm going to subtract this 2. And I think the answer there will be 214. So that's what I'm going to get. So in other words, the derivative of the integral of that, given the upper limits and the lower limits, will give you 240. All right. Okay. So now, the next one, I'm now going to give it to you guys. This is your question now. I want you to do it because this is not very challenging. I'll give you 2 minutes to do this one because this is quite an easy one to do. Okay, your 2 minutes will start now. Okay, welcome back. Our WhatsApp number is 079-578-2908. Let's see what you have done with that question. And I hope and trust everybody got an answer of 0. If you did not get that, just check what you have done. Okay, but let's see how we get the 0 here. So here, we are now going to integrate. Let's integrate this one. So immediately I'm going to integrate. I don't have any problems here, so I just integrate with this one. So what am I going to have? I'm going to have the integration of that will be x to the power of 4 all over 4. But now remember what I must do. I must then put my upper limit and my lower limit. So it's 2 to minus 2. Okay. So here, I'm already done with my upper limit and my lower limit. What should I do? Then I'm going to I'm now going to substitute. Firstly, I must substitute by 2. So I'm going to have 2 to the power of 4 all over 4. I'm done with the 2. So I'm now going to substitute by negative 2. And I must put a minus, remember. Okay, so because it's the upper minus the lower. So here I'm going to have my negative 2 to the power of 4 divided by 4. Then I'm now going to have that. So I have that. Now I need to just work that one out. 2 to the power of 4, it's 16. 16 divided by 4, it's 4. Minus 2 to the power of 4, it's 16. Positive 16. 16 divided by 4, it's 4. So my 4 minus a 4 is a 0. So meaning that that function there, the cubic function there, if I've got minus 2 and plus 2, the 2 will, the summation there will be 0. Okay, so that will be 4 minus 4, which is 0. Nice one. Now, now I have 2 over x. Can I differentiate when I have, can I integrate when I have something like that? No. What should I do? I must then write it properly. Before I integrate, I must write it properly. So I'm going to write it there, upper limit, lower limit. Then I'm going to have my 2x cubed minus 2x to the power minus 1. Okay, because that x here is 1, so I must go up there, it must be minus 1. And now I realize, oh, but I know something about 1 over x. 1 over x. Oh, what should I do with 1 over x? Oh, I didn't know. Now I know. It's ln of x. But now I've got a 2. What should I do? Now I've got this 2 here. What should I do with that 2? So it is going to be 2 ln of x. All right. So meaning that if I want to integrate 2 over x dx, that will give me 2 ln x. That part, I'm done. I'm fine with it. I'm going to be fine. So I don't need that. I don't need that because I know I'm going to say minus 1 plus 1, it gives me a 0 divided by 0 again. Then I have a challenge with division by 0. So meaning that I'm now going to look at this and say, okay, now how am I going to integrate this? The answer to this will be equals to 2x cubed. Sorry, not 2x cubed. What should I have? X to the power of 4. Just going to erase that. Sorry. I'm integrating, remember, it's x to the power of 4 divided by 2. By now, I know you know how to integrate. Né? So it's 3 plus 1, it's 4. And 2 divided by 4 is going to be 1 over 2. Right. And then from there, what do I do with that ln? I'm going to say minus 2 ln of x. But now, remember, I have boundaries here. It's 2 it's 2 and 1. Now, how am I going to substitute this? Sure. How am I going to substitute this? Now I'm going to try to substitute. First of all, I must substitute by 2 then I substitute by 1. So I'm going to have my boundaries, then minus the other one. I'm going to prefer writing it like this now. Okay, so now first I'm going to substitute by 2. So I'm going to say 2 to the power of 4 divided by 2 minus 2 ln of 2. Oh no, yo, what am I going to do with this ln of 2? Am I going to get an answer? Don't worry, let's leave it like that for now. The other one that I'm going to do now is to substitute the value of x by negative 2. So I've already I've substituted by 2, now I must substitute by 1. So I'm going to say 1 to the power of 4 divided by 2 minus 2 ln of 1. Okay, so now I can take out my calculator that I'm going to use now. I'm now going to say 2 to the power 4 over 2, so 16 divided by 2, which is going to give me 8. So I can write that 8 minus 2 ln 2, right? Then minus, there it's going to be my half, minus 2 ln 1. Ln 1. Right. If I take out my calculator in this instance, I'm going to have 8. You can do it with me. It's 8 minus 2. In your calculator, please look for ln, ln. You'll find it there. There's ln on your calculator. Please look for it and use that button. So you're going to say 8 minus 2 ln. You press 2, you close the bracket, and you get your answer. From there, you say minus half minus 2 ln 1. And then from there, you say equals 2. And the answer that I got here, it's 6,11. That's my final answer that I got there. So please do it and check with me. Check for me if my answer is correct. Because I've done it now, it's 6.11. Then I write that one. Remember, we write answers correct to 2 decimal places unless stated otherwise. Okay, we're getting along there. Now, the next part that I'm going to do, which is also very important. This question is always there in an exam. It's always there. Questions like this are always there in our exam. Now we want to find the area, the magnitude area of a function that is given. Most of the time every time they're going to draw you a function, and with this function, they're going to be given an equation on that function, and you're also going to be given the limits. So you'll have your upper limit and your lower limit. So, or you can be given that as an interval. In this case, it is given as an interval. So they say between 1 and 3. So I have an interval of 1 and 3. So the graph of this is given as that. It's sketched alongside. Find the area enclosed. Remember, the area will always be enclosed on the x-axis and the function, you see. So we want the area of that thing there. And when I look at that figure, just to find the area, it might be a bit of a challenge to get a formula. And then from there, I need to do, that part will be my challenge to get the area of, if I've got a part here, so I just need to get, I know that side and that side, I can get the length of that side. But remember, now we want to work in pieces. So I'm going to get the area of this part. I must get the area of that. I must first get the length of this side by substituting that and substituting that, and try to get the radius, and that will be a lot of work to do. Okay, or I can just divide this one into parts. I can divide this into parts, and from there I can add the parts. But we'll go to easy way of doing that. So the easy way of doing that will be to first integrate and use the boundaries as we have done in the last activity. Can you see why the last activity was important? it is because we were going to use those that activity to then do the area, because now we've got the boundaries. So the area between, which is enclosed in the x-axis, yes, it will always be on the x-axis, and or between the two graphs, if there are two graphs that has been given. In this case, we have got only one graph, so we just need to find the area of that part. Now, let's look at this. What do we do? First thing that we do, what do we do here? Let's look at it. 5 marks for 5 marks. Remember, if I've got that question here for 5 marks with an indefinite integral and the one on definite integral, and then I have this one on the area, done with my 15 marks. Once I practice all those 3 things, I'm done. This 15 marks is all yours at the end of the year. Right. The graph of H is given by that. So what am I going to do? I'm going to write down what the area is. So the area of this figure will be the integral with boundaries 3 and 1, upper limit and lower limit, of the function x squared plus 4x dx. Nice. So now I'm now going to write down do the integral of that. Integral, straight to integral, I'm going to get, what am I going to get if I go straight to my integral? This function, sorry, there's a minus here. There's a minus there on this function. So therefore we have a minus because it's a graph that is facing downwards. So there must be a negative there. So now how am I going to do my integral here now? So I'm going to have my negative 1 over 3 x to the power of 3. That's my integral for the first part. For the second part, what is my integral? It will be plus 2x squared. All right. Then I'm now going to put my boundaries, which is going to be 3 and 1. So from 3 to 1. So I need that area here from 1 to 3. That's what I need. So obviously, most of the time I prefer that you have your upper, your upper limit is the number there must be bigger than the one on the lower limit. So the upper limit there is 3, the lower one will be 1. So 3, 1. Bigger one on top, smaller one at the bottom. It makes life easy for you. Okay. Right. Now, what am I going to do here? Now, I'm going to do the very same thing that I was doing previously by doing what? By adding. By substituting, sorry. So I'm going to then do that and substitute there, again and substitute there. Then I'm going to have my answers here. Okay, so I'm going to say negative 1 over 3, substitute first by what? By 3 cubed, then plus 2 into 3 squared. So I'm done with the 3. So then I'm substituting by 1. So I'm going to have negative 1 over 3, substitute by 1 cubed, plus 2, substitute by 1 squared. From here, I use my calculator. Use my calculator correctly. I'm now going to have, if I substituted there, that part there will be 9. Okay, because it will be 3 cubed is 27. Then I'm going to have a minus 9 there. Then from there, I'm going to have plus 18, which is going to be positive 9. In the next one here, if I substitute correctly, if I work it out correctly on my calculator, I'm now going to have 1 cubed, which is going to be 1. And then from there, we have minus 1 over 3 times 1 is minus 1. So I'm going to have that one is minus 1 over 3. Then from there, the other one will be plus 2. So if I add minus 1 over 3 plus 2, then the answer there will be 5 over 3. Okay, because there will be 6 minus 1, which is 5. If I subtract this 2, I'm going to get 22 over 3 square units. Remember, now I'm working with the area. And the area is never negative, but we say the area is above the x-axis or below the x-axis. So if I get a negative, it means that is the area below the x-axis. If I get a positive, I know that is the area above the x-axis. In this case, I got positive value, which means that is the area which is above the x-axis. So if you get a negative value for this question, then it means that there's something wrong that you have done, your calculations there, or calculator usage was not correct, because the area of that is above the x-axis, then it is bound to be a positive value. That's why we got positive 22/3. Okay. Right. Now, and that's before I go on, that it's 5 marks. And once you understand this, then you have your 5 marks. Okay. Right. The following sketch here. So again, what should I know? Immediately, I already know that my area is above the x-axis. So it's above the x-axis, which means that I'm going to have a positive area. So that area can never be negative. Okay, the answer that I'm going to get will never be negative. So now here, what do I have? Oh, I have that 2/x. This one I already know my answer. So I know how am I going to get my answer. First, what do I write? I first write down the area. It's equals to the integral 3 and 1. Because my boundaries there, it's 3 and 1. You'll realize that they always write x-axis and the other two coordinates. So it's the x-axis and the other two boundaries here. So that's the area. So I need the area of that. So to find the area, if I'm trying to be smart, it means that I have to then divide this into pieces, and from there get the area of each and every component, which is going to take me forever. The easy way is to do the integral. We're applying the integral now to put those pieces together and try to get the area of the whole shaded part. In this case, now I've got 2/x dx. Now I already know that the integral of 2/x is going to be 2 ln x. So what do? I can then write this one as 2 open bracket ln x. And then I write down my boundaries, which are going to be 3 and 1. Don't forget to write your upper limit and your lower limit there, because you have a mark for that, just to write in those two. So here I'm going to write equals to. Now remember, I've already integrated the sign, it's gone. Next, what should I do? I then substitute my value of x. So I'm going to have 2 brackets. Okay, right? So I'm going to have, or the easy one to do will be now to write only 1 bracket and put the 2 outside. So I'm just going to subtract. So I'm going to have ln of 3 minus the ln of 1. Okay, without those brackets. Remember now? Then I just take my calculator. I hope everybody now has already found that button, the ln, the ln button. Okay, so now on your calculator. Work it out on the calculator. I got 2.20 square. Don't forget to write the units. It's square units. That is the area of this part here. So that area of this part will be 2.20 square units. Getting right up. Okay, now the next question is also based on how to find the area of that figure now. Yeah. Now, I want us to look at this and try to do this question. I want us to try and do this question. I'm going to give you 3 minutes to do it. 3 minutes to do that question. Let's see who can get that question. And once you have done it, take a picture and send it to 079 578 2908. Your 3 minutes starting now. Okay, welcome back. Hope and trust you're already done with that question, and you are wondering what is happening with this question. So when I do that, and we have the area, because we have an area of this part here, I've got the area, that part there, and from there, why am I getting the answer that I'm getting? Something wrong maybe with the question. No, there's nothing wrong with the question. Let's see what we're going to do. Because I think I've got the area, but let me see what, maybe I'm also confused here. Let me see. Now, the area will be the derivative, the integral of 2 there and minus 2. Then we have our function 3x cubed minus 12x dx. Okay, now the integral of that will be, remember I must put my boundaries there. So it's going to be 3 over 4 x to the power of 4 minus 6x squared. And I must put my boundaries. So my boundaries is going to be 2 and minus 2. So my upper limit and my lower limit. Now, if I substitute here, then I say minus. Remember now what do we have? I have the area above the x-axis and the area below the x-axis, but I want the combined area. Okay, so now, what must I do here? So I'm going to say, I substitute now. It's 3 over 4, 2 to the power 4, minus, that will be 6 into 2 squared. That side will be 3 over 4, minus 2 to the power of 4, minus 6 into minus 2 to the power of 2. Now I take out my calculator, calculate this, no problem, I'm calculating now. That will give me, then it gives me 0. An area cannot be 0. What did I do wrong here? Now we have that area that is below, and that other one is above. Because when I calculated that, then I get 12 minus 12, which is going to give me a 0. What should I do? No problem. Look at what I'm going to do now. Because I can see that the distance from here to there is the same as the distance from here to there. They're obviously in that graph, then I'm going to get a big 0. What should I do? Then I must separate the two. I must separate the two areas. So I'm going to first do the area of that part, area 1, and I'm also going to do area 2, and then I add the two areas. Oh, that's exactly what I'm going to do. Because I can see the area of this part is the same as the area of that part. So I'm going to separate the two and do them separately. So what am I going to do now? I'm now going to do them separately. So now I'm now going to erase this because I really do not need this. I'm going to erase this. I know you have done it, and I know some of you have copied it down. You can then erase it with me. Okay, so now I'm going to then go to my pen there. So I'm going to then do that. So I'm going to have one part first, and then I'm going to do the other part first. So I'm going to say the integral of minus 2. So I'm going to say 0 and minus 2. I'm going to find the integral of this part first. So I'm going to say 3 there and minus 12x. Right, dx. So I'm going to start from here to minus 2 to get the area of that part. And that area of the part must give me a positive value. Reason, it is above the x-axis. So I'm now going to integrate this. So I'm going to have a 3 over 4 x to the power of 4 minus 6x squared. And then my boundaries now it's 0 and minus 2. So if I substitute this, I'm going to have this part here minus this part there. So I'm going to have 3 over 4 into 0 to the power of 4 minus 6 into a 0 squared. This side I'm going to have 3 over 4 into minus 2 squared to the power of 4 minus 6 into minus 2 squared. So here I know I'm going to get a 0. I'm going to get a 0 here. Then I'm going to say minus into. Right. So if I check this one, my answer there, it's going to be a negative 12. So I'm going to get a negative 12 here. If I work that one out. So after getting a negative 12, then I'm going to then say negative and negative will be 12. So the area of 1 will be 12. Similarly, I'm going to do the same with 0. I'm going to do the same here as, I'm going to write it here. I'm going to do the same as that of 2 and 0, because there will be 2 upper limit and 0 lower limit. So if I do this one, and I'm going to let you do that one on your own. So if I integrate that, after integrating and substitute by 2 and by 0, the answer that I get there will be negative 12. But remember here we are talking area. So the area can never be negative. Okay, so therefore, we're going to say our area is going to be, area of 2 is going to be 12 square units. Square units. Right. Here I have 12 square units. So what am I going to do to get the area of the whole now, of the whole shaded part? I'm going to say the area of the shaded, it's equals to area 1 plus area 2, which then gives me 24 square units. Very interesting question. So meaning that you have to then do area 1, especially when you see that the distances between those two will be the same. Then I can then use that. But yeah, if the distances, that part here, the area of that and the area of that are not the same, and the units there, you can see there we have a minus 2 on this side, 2, so the distances are the same on both sides. So that is why then you have to do the area of part 1 and the area of part 2. But I'll recommend that we always do, if I've got those two parts, which the other one is on top, above the x-axis, the other one below the x-axis, I think it is going to be very safe for you to first do the area of the one part, then the area of the other part, then you add them together, combine them together. If it's a negative one, then you make it positive, because we don't have the area. The area can never be 0, it can never be negative. Okay, so on the first one, remember we got the area to be 0, and that did not make sense to us, because we've got a surface there which must be a number which is above 0. It cannot be a number which is 0 or below 0. So here it is below the x-axis. There it's above the x-axis. So I've got those two. So make sure that you understand this type of question, because the examiners can be a bit tricky with this question here. Let's make sure that we understand it. All right. Now, here's another one. Now you look at this one and say, okay, basically it looks like the same. I think we can play around with it. But look at this now. The distance from here to there is not the same as the distance from there to there. So I don't think there we're going to pick up challenges, because there we have the area below the x-axis, which is going to give us a negative area, negative value. This one is going to be above the x-axis, which is going to be a positive value. So in other words, remember, if it's a negative value, then we're going to then try to make it a positive, so that then we can add the two areas together. But the other thing that you can do is, you can first find the area of this part by using 0 and negative 4. Then we get an area which is going to give you a negative number in that case. You get the area of 0 to 0, 0,5. Then from there you take the two values, you add them together because you need the area of the whole shaded area. So the area of the whole shaded part. So you have got two ways to do that. You can either do it at once and say the area is going to be the integral of, I prefer putting the bigger number on top and the smaller number at the bottom. Then from there, what do we do with that equation now? Can you see it's x into 5 plus 3x. So what should I do first? I then need to multiply x inside the bracket. I'm going to get 5x plus 3x squared of dx. So I said we've got two ways to do that. Is that I'm going to do it like that, or I'm going to then say the integral of area 1. So the integral of area 1 will be between 0 and minus 1. So I'm going to put a 0 there and minus 1. And plus, or the total area, let me just say the total area. Then of this part here, 5x plus 3x squared, plus the area of the integral of 0, 0,5 and 0 of the same thing there. I'm just going to write f of x, right, of dx, h of x. Right. So I can first do that one and then do that one, then from there add them together. Or I can do it from 0, 0,5 to minus 1. So I still get the same answer. Okay, so let me do this one. So from here, what do? We are now going to integrate. Now, let's integrate here. So if I quickly integrate here, the answer that I'm going to get there will be 5 over 2. And then I'm going to get x squared. And then plus x cubed. Then my boundary is going to be 0, 0,5 and minus 1. Okay, so from there, I'm now going to substitute. And once I substituted, then I'm going to get the final answer. Then I'm going to say 5 over 2. First substitute by 0, 0,5 squared plus 0, 0,5 squared. Sorry. Right. Now, in the next brackets, I'm now going to substitute by negative 1. So substitute by negative 1. So there's no squared here. Oh, sorry, yes, there's a squared. Yes, because I'm using the one with the integrated one. So it's 5 over 2 squared. This is cubed. Squared. And then plus minus 1 cubed. Then from there, I'm now going to take my calculator out, then use my calculator correctly, correct brackets. Then from there, it's 5 over 2, 0, 0,5 all squared, the way it is. So you just put bracket, 5 over 2, open bracket, 0, 0,5 all squared, plus 0, 0,5 cubed, then minus 5 over 2, open bracket, 5 over 2, open bracket, minus 1 squared plus minus 1 all cubed. So meaning that it will be the area from here to there, the shaded part. Can you see it is between the function, the curve, and the x-axis, between the boundaries. You see, this is the curve, this is x-axis, below negative, there positive. So you can either use that part here, total area, by separating the two areas. So you can have area 1 and area 2, work them separately, add the two, and then from there you have the same answer. So the answer that we're going to getting here, it's going to be 2,25. Don't forget, you must write square units. That's my final answer. So it is very, very, very important that we understand the three things that we have done today to use your rules to get answers on definite integrals and also on the indefinite integrals. Remember, the definite integrals will be the ones that has got an upper limit and a lower limit. The indefinite integral does not have limits. So there you just have your answer with your pieces that has been prescribed on that question. But with definite integral, we need the values. The other questions that they can be asked in this one is that you might be given the area of the figure, and we now need the upper limit. So in other words, you can be given the area here. So the area of the figure, it's this, and then from there find the upper limit. You find that they've given you that, and they say this is x and this is -2. And then from there, they've given you a function. I'm going to write the function here, 5x plus 3x squared. Then from there, they say the area of that is 2.25. Then they need you to find the value of x. So your area is given, so you just need to find the values of x. Thank you so much. Please keep on practicing this technical math. And this topic really is a very interesting topic with 15 marks, as I said, and I hope and trust you'll get this 15 marks at the end of the year. Keep practicing, and thank you so much.